Okay, so this unit is called rational expressions. And today we're going to simplify our rational expressions. More so you can think of rational expressions as fractions. However, they're going to have, they'll be algebraic fractions, meaning that they will have x's in them. So they're not our normal fraction look of like 1/3 or 2/5. And so the first part is we're going to end up simplifying these rational expressions. Undefined is also on the same day, but we're going to save that for a different day. Here we go. So there's some directions up here. We're going to simplify some monomials, which are single terms in the fractions. However, if they're binomials or trinomials, we have to remember that in order to simplify them, we're going to have to factor them first. There's a quick example here that if this is that's a monomial divided by a monomial, what you do is you simplify your coefficients first. For instance, 3 goes into 3 once, 3 goes into 6 twice, and so that becomes the 1/2 you see in the next step. When we have x to the fifth and x squared, if you think of x to the fifth as being x times x times x times x times x, all divided by x squared, which if you think of as x times x, what happens is that x divided by x reduces to 1. X divided by x reduces to 1. And so we end up with a 1 times a 1 times an x times an x times an x, which is really just x to the third. And so we have to talk about what is the rule when you're dividing and they have the same base. What do you do with the exponents? The trick is to subtract them. 5 minus 2 is 3. And that's how we get that 1/2 x to the third. And sometimes this guy right here, we have to decide if he lives on the top in the numerator or on the bottom with the denominator. And remember, if it's off to the side like that, you can always make it a fraction by putting it over 1. So you can see that the x cubed actually lives in the numerator. And so there's our answer. Now, if we have binomials and trinomials, like in this example over here, on the top is a binomial and on the bottom is a trinomial. And in order to reduce a fraction that has those in it, we have to make sure that we're reducing factors, not terms. In the monomials, there's multiplication between the 3 and the x to the fifth on the top and the 6 and the x squared on the bottom. And that's why we could go ahead and reduce those. But in this one, this is actually a term, and this is 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 a term. And we cannot cancel or reduce terms. We can only cancel or reduce factors. Well, we don't get factors unless we factor. And so that's why we spent so much time in Unit 1 factoring. So if we look at this guy right here, greatest common factor, we pull out a 3, and we would be left with an x minus 2, like in the next step here. Okay, on the bottom, that's an easy trinomial, and so we multiply to -10 and add to 3, and we're going to find out that the numbers are 5 and -2, and then we could go ahead and factor, and it looks like this. Now that it's factored, now we can cancel common factors, and so you guys can see there's a pair of x minus 2's here, and they're going to be gone, leaving you with the 3 on top and the x plus 5 on the bottom. Okay, there's one more thing we have to talk about when we reduce, and that's going to be taken care of in this next part, A through E, and it's asking you to reduce the following if possible. And it's going to help, these first 2 examples with numbers are going to help you understand the next 3 examples with letters. And so in A, 9 minus 6 is equal to 3. On the bottom, 6 minus 9 is equal to -3. And 3 divided by -3 is equal to -1. Okay, same thing in part B, 15 minus 3 is 12. 3 minus 15 is -12. And 12 divided by -12 is equal to -1. So what those 2 examples are trying to show you is if you have subtraction between your 2 numbers or your 2 terms and you switch the order on the bottom, what is each one of the fractions reduced to is -1. So that's hard to see when I take the numbers away and change them to A's and B's, but hopefully you're seeing, okay, and the whole point of it, see this positive A on top, but the A on the bottom is negative. So those are opposites. At least that's what I call them. Okay. And on the top here, your B is negative, but on the bottom, your B is positive. And so the A's are opposites, the B's are opposites, and hopefully you guys can see that that's the case here too. This 15 was positive, this 15 is negative, this 3 is negative, this 3 is positive. So those were opposites, and so you can compare the two examples. And so what we're going to have to realize is when there are complete opposites of each other, they will always reduce to a -1. Okay, just like they did here and here. Easier to see what the numbers can do. You can do the math and actually do the subtraction and then the division, but you can't do that really when you have those variables. Okay, so in part D, we want to figure out, is that the same thing? Are those a pair of opposites? And they're actually not. This A here is positive and this A is positive. So the A's are actually both the same sign. The B here is positive and the B here is positive. And so if you think about it, you can switch these around with your commutative property with addition. But both A's are positive, both B's are positive, and so this isn't going to reduce to -1 because they're not opposites. It's going to reduce to +1. Okay. Now in part E, this A here is positive, this A here is positive. So those are the same. This B is positive and this B is negative. So the A's are the same, the B's are opposite. So it's like a combo of what we did in C and D. And so what's going to happen is nothing. This doesn't reduce at all. All right. And so we have to make sure that we know and understand these three cases when we're simplifying. Okay. And we'll talk about them when we start doing some examples. Okay. So going down in number 1. That is a monomial over a monomial, and it cannot be factored. And that's okay because between the numbers and all the letters is multiplication, which makes everything a factor. And so you could go ahead and just start reducing it. So I always do numbers first, just like the one we did up there. 3 goes into 3 once, 3 goes into 6 twice. We have those exponents, okay? And I know I said subtract them. However, 5 minus 8 gives you a -3, and we really haven't talked about negative exponents yet. So what I do is I like to say, well, these 5 x's would have canceled with 5 of the x's from here, leaving you with 3 x's on the bottom left. I always think that there's more x's on the bottom, right? Same thing with the y's, and you could do the subtraction if you want. Again, I like to say, well, these 3 y's would be gone and they would cancel with 3 of the y's from here, leaving 3 y's left on top because there were more y's on top. Then what I do is I like to go ahead and collect everything on top, which is a 1y cubed, over, collect everything on the bottom, a 2x to the third. The only thing you don't really need is that one on top since the y cubed is there. If the y cubed wasn't there, then yes, you need the one on there to have something in your numerator. But if there's something else there, then you don't need it. And here is our answer in simplest form. Okay, so number 2, we'll try again. 8 does not go into 20. However, I have to think about the largest number that does, or you can go ahead and do 20 divided by 8 math frac in your calculator and it'll reduce it for you. But the biggest number that goes into 20 and 8 is 4. So 4 goes into 20 5 times. 4 goes into 8 2 times. Okay. This x squared would be gone and cancel with 2 of the x's on top, leaving you 8 x's left, aka x to the 8th. There are no y's on the bottom, and so that y to the 8th is going to have to stay. And so if I collect everything on top, we end up with a 5, x to the 8th, y to the 8th, all divided by, on the bottom, we just have a 2. And that's in simplest form. And you reduced a fraction or simplified a fraction. Okay. All right, so number 3 changes because that is not all a monomial on top. It's actually a binomial on top and a binomial on the bottom. And in order to reduce this, you have to make sure that you're reducing factors, and you're not going to get factors unless you factor. And so on top, this is a D2PS. And so we're going to go ahead and factor them into x plus 1 and x minus 1. Okay, right? Remember that from last packet? Okay. On the bottom, there is a greatest common factor, and so we're going to go ahead and pull out an x because that's what's in common. Left over would be an x plus 1. Okay. Now that they're both factored, now we cancel common factors. The x plus 1 factor is common on top and on the bottom, and so those go away. And what we have left is the x minus 1 factor over x. Okay. Some people will be tempted to cancel these x's, but you have to realize the x on top. See how he has subtraction after him? Therefore, he's not a factor because factors have multiplication after them. So what some people will do is that they'll leave them in parentheses to remind yourself that that's together. You cannot separate it. Unless you could factor it, but we already factored and we know that that's not factorable. And so we'll close it up, box it up, and that one is finished. Okay, let's try some more like that. So in number 4, again, you have addition and subtraction between your terms, and that's why those aren't factors. Factors have multiplication. So in order to cancel factors, in order to reduce this fraction, we're going to have to go ahead and factor the top and factor the bottom if possible. And on the top, if you notice, that is an easy trinomial. So we'll set up our x box, multiply to negative 10 and add to 3. We're going to find the numbers as 5 and 2, except the 2 has to be negative to get the positive 3 out. Okay, and then we can go ahead and factor it. On top, it would be an x plus 5 over an x minus, or I'm sorry, next to an x minus 2. Okay, so this becomes this. Okay. On the bottom, that is the greatest common factor, and we can pull out an x. And when we pull out an x, we'll be left with a 5 minus x. Okay, now that everybody's factored, now we look for common factors. And on top and on bottom, you probably see the x plus 5 and the 5 minus x. And so that's one of those 3 situations up there that we have to kind of think about. This x is positive, this x is negative, so they're opposites. This 5 is positive and this 5 is positive. Well, they're not exact opposites and they're not completely the same. You got one of each. The x's are opposites, but the 5s are the same. Therefore, this is that last situation up there where nothing will reduce. And so even though we tried to factor it in order to reduce it, nothing will reduce. Most people will be tempted to cancel those x plus 5 and 5 minus x, but you can't. They don't reduce to 1 and they don't reduce to negative 1, and so you cannot cancel them. Okay. All right, number 5. Again, it's a binomial and a trinomial, and they need to be factored if you want to reduce this fraction. Okay, so on top, that looks like a greatest common factor again. And so we are going to go ahead and pull out an x and be left with 6 minus x. On the bottom, that's a nice easy trinomial. So off to the side, multiply to 6 and add to negative 7. Hopefully you know the numbers are 6 and 1. However, they're going to have to be negative 6 and negative 1 to get that negative 7 on the bottom and the positive 6 on the top. Okay. And he's an easy trinomial, so we can go right to our parentheses and factor them up into x minus 6 and x minus 1. Okay, so now we have to look for a pair of common factors. And you guys are probably looking at the 6 minus x and the x minus 6. And it's going to be one of those cases up at the top again. And so we have to figure out which one it is it. So if we look at the 6 here, it's positive. The 6 here is negative. So that's opposite. This x here is negative and this x here is positive. And so they're opposite. And so this is that third case up there where you have both terms being opposites of each other, the 6's and the x's. And so when they are complete opposites of each other, you are allowed to reduce them to a negative 1. Okay, and I'm not going to lie to you, I usually don't put negative 1, especially when there's still something up here. I usually just put a negative sign, okay, because negative 1 times x is the same thing as negative x. So we're going to say that this is equal to negative x on top over x minus 1 on the bottom. And again, if you need to put those parentheses around that factor to remind you that that x cannot be separated from the 1, some teachers, math teachers call them that they're married, cannot break them up. That might help you too. And then we could go ahead and box this together. Okay. All right, number 6. So on the top, I just wanted to circle this real quick and show you that that's where that went, okay? On the top, and again, these are binomials, which means they have addition or subtraction between their terms, not multiplication, so they're not factors until we actually do the factoring. On the top, we have what looks like nothing in common, but it does seem like it's a difference of 2 perfect squares. And so we're going to go ahead and factor it into 1 plus and minus, and this will be a 2x. All right, now the top is finished, and now we can go ahead and do the bottom. That is the greatest common factor of 5, and when we pull it out, we'd have a 2x left minus 1. All right, so we have that. Another one of those cases, which is why we had to talk about them. Everybody see the 1 minus 2x and the 2x minus 1. So if we look here, that 1 is positive, that 1 is negative. So that's a pair of opposites. Looking at that 2x, it's negative. Looking at this 2x, it's positive. And so we have a pair of opposites with the 1s and a pair of opposites with the 2x's. And so they're complete opposites of each other. And you are allowed to go ahead and reduce them, but you have to reduce them to a negative 1. Okay. And negative 1 times that is just that stuff negative. So we'll go ahead and put the negative. And then we have to make sure that this stays in parentheses unless you distribute the negative. On the bottom will be a 5. Okay. So that is one answer. If you want to go ahead and distribute the negative, you could, and you would get a negative 1 minus 2x over 5. That's a fine answer as well. Some people will actually take the negative and not put it with the numerator. They'll put it with the denominator. And so your answer could also look like this. And that's also fine. Okay. So all 3 of those answers are good to go. You do not have to put all of them, though. You put whichever one you think is best. So I will tell you what I do. I always leave the negative on the top, and I never, ever distribute it. Okay, because sometimes when you distribute it, you make mistakes. However, if the question is multiple choice, you might have to distribute it in order to pick your choice. And so that gets a little bit tricky. Okay, I never put my negative on the bottom. However, again, in multiple choice, they might put the negative on the bottom. And so you just have to compare and see which one is equivalent to your answer. Okay, we'll see you on the back side of notes.